Welcome to lecture number 39. Now 39 lecture is next to basic proportionality theorem, and here we are going to prove three different tests of similarity. Before that, let us define similarity. What do we mean by similarity? We say two triangles, triangle ABC and triangle PQR are similar. Two triangles are said to be similar if and only if. So similar if and only if, that means if this happens they are similar. If two triangles are similar, then this is true. If and only if, always both ways. So if two triangles are similar, one, their sides are proportional, that is AB upon PQ is equal to BC upon QR is equal to AC upon PR. This is one thing which should happen. And second, all the angles must be correspondingly congruent. Angle B congruent to angle Q, triangle C congruent to angle R, and 4 angle A congruent to angle P. So if these four things happen, then triangles are similar. If triangles are similar, we get these four things as a deduction, as a result of similarity. Now in congruency, we similarly had 6 different characteristics of triangle, 3 sides and 3 angles. So 6 things are congruent correspondingly to the other triangle. Then the 2 triangles are congruent, or if 2 triangles are congruent, then these 6 are supposed to be congruent. And then we said efficiency theorem. We need not have to always prove all the 6, but it is okay if we take 3 of them and prove 2 triangles congruent, then we get 3 more as our deductions. And therefore those efficiency theorems for congruency were congruency tests, basically 5 of them. Similarly, we have similarity test, and there are 3, basically 3 similarity tests. First test of similarity is AA. If any 2 angles of one triangle is correspondingly congruent to the other, then these 2 triangles are congruent. So we will use, out of 4, we will use any 2 of them and deduce that remaining 2 are also true. Second test is SAS. In SAS test, what we will do is we will use 2 ratios, say AB upon PQ and BC upon QR, they are equal. Then the included angle B and included angle Q, if they are congruent, then 2 triangles must be similar. So out of the first 2 ratios and include second. So again we are using only 2 conditions, and then we deduce remaining conditions in SAS. And the third test of similarity is SSS, where we use first completely AB upon PQ is equal to BC upon QR is equal to AC upon PR, and hence triangles are similar by SSS. And if the triangles are similar by SSS, then these 3 corresponding angles must be equal. Now this lecture contains basically proving all these 3 tests. So let us do first one, AA test of similarity. AA test of similarity. I am given 2 triangles which are ABC and PQR, and the given information is AA. Suppose this angle is equal to this, A is congruent to P, and B is congruent to Q. So of course we can deduce that the third angle is also equal, because angle sum is 180. So AA means actually AAA. So the third angle is also equal by using angle sum property. Now the proof goes like this. You take PQ and put it on AB, so you get point M here, such that AM is equal to PQ. You take PR and put it on AC, you get point here, which is N, such that AN is equal to PR. Join MN. So if we join MN, what we have done is basically by SAS, we have copied triangle PQR on ABC, and hence AMN is congruent to PQR. Triangle AMN is congruent to triangle PQR, right? Now, because AMN is congruent to PQR, this angle is also equal to B and this angle is also equal to C, and hence by corresponding angle test, these two lines are parallel. So, MN parallel BC by corresponding angles. Now, because MN is parallel to BC, we have BPT in place. BPT says AM upon AB is equal to AN upon AC. Extension of BPT says this. Now, because the information about angles were given, we copied that angle and we got the information about sides. Now, AM upon AB can always be converted. This is extension of BPT. Similarly, if we would have copied this angle in this other corner, we would have got the other ratio, one more ratio, and hence all the three ratios required for proving these three. Basically, we have got these three in place that was given to us. We are supposed to prove these three equal, and that is how we will be able to do it. So, if two angles are given, you cut and paste that triangle on the bigger one, and then show that they are parallel using BPT. This is by BPT, EBPT. And if you repeat this procedure of cutting and pasting onto the other angles, we will be able to get the third ratio, right? So this is what is a AA test of similarity. Now let us look at SAS test of similarity. SAS. So SAS in triangle ABC again and triangle PQR, SAS means what is given to us? It is given that AB upon PQ, or let us take smaller upon bigger, PQ upon AB is equal to PR upon AC. This is given 1, and 2, angle A is congruent to angle P, included angle given. These are the given things, SAS. Two sides ratios and one angle which is included. So SAS is given to us, and now what we are supposed to prove? A is congruent to P, this is given, and these two ratios, PQ upon AB and PR upon AC, these two things are given. So these two things are given, and we are supposed to prove that the third ratio is also equal to this, and these two angles are congruent. This is what we are supposed to prove. So again, the trick is exactly same. You copy this triangle over here, and because this angle is equal to this, by SAS these two triangles will be congruent. Triangle PQR is congruent to triangle AMN, right? And now the ratios are given. PQ upon AB is equal to PR upon AC. So if PQ is equal to AM, what do we mean by that? AM upon AB is equal to AN upon AC. So this is given to us. AM upon AB is equal to AN upon AC is given to us. By converse of BPT, we get MN parallel BC. By converse of BPT. Now, if MN is parallel to BC, then of course these two angles will be equal. And already we have proved that PQR is congruent to AMN, therefore correspondingly these two angles are also equal. So B is equal to Q and C is equal to R. That is what we wanted to achieve. We achieved it, and we can directly say now, therefore triangle ABC is similar to triangle PQR by AA test, because all the three angles are same. This is the trick. So we have to use the given information that these ratios are equal, and then copy paste the triangle on the other triangle. So this is proof of SAS test of similarity. Now let us do the third one, SAS. It is little involved. So let us do SAS. Now in SSS, what is important is that we have not been given any angle, and that makes things little difficult. So what is given to us, not this angle, but PQ upon AB is equal to PR upon AC is equal to QR upon BC. QR upon BC. This is given to us. So only condition number 1 is given to us, all three of them. We are supposed to prove all three angles equal. And now I request you to note each and every small step properly, because this is the most difficult test to prove in similarity, SSS. Okay. Why? Because no information about any angle is given. If this angle was congruent to this, I can cut and paste this triangle onto the bigger triangle. But now it is not going to happen. So now I will take point M randomly and point N randomly, such that PQ equals AM, PR equals AM. Join MN. Join MN. Okay. Now what is happening is PQ upon AB, given condition. Let us look at given condition. PQ upon AB, which I can say PQ is congruent to AB, therefore AM upon AB is equal to PR upon AC, so AN upon AC. So using these two and the construction, I could get this result. AM upon AB is equal to AN upon AC. But if AM upon AB is equal to AN upon AC, then the lines are parallel. This implies MN is parallel to BC by converse of BPT. And now if MN is parallel to BC by converse of BPT, then BC, this angle is equal to this angle. This implies angle B equals angle M and angle C congruent to angle N. This is what we got. This angle equals this angle, right? Now, therefore, we are supposed to show now triangle AMN is okay. So triangle AMN is similar to triangle ABC. Triangle AMN is similar to triangle ABC, and therefore MN upon BC is also equal to AM upon AB, which is AN upon AC. MN upon BC, because these two triangles are similar, the third ratio MN upon BC is also similar, proportional, MN upon BC. However, in the given equation, we have been given this, which is we have not used, which is equal to QR upon BC. So if we compare MN upon BC and QR upon BC, what we get? We get MN equal to QR. Now, so AM is anyway equal to PQ, AN is anyway equal to PR by construction, and now we have proved MN is congruent to QR. Therefore, by SSS, AMN is congruent to PQR. AMN was similar to ABC. Therefore, PQR is similar to ABC. So, this is the involved third proof for SSS. Now, you may just go through this video again and again, pausing it, going it slowly, and understanding each and every step. You will realize that all these proofs are not very difficult, but little involved. Last one, first two are easy, and if you have understood this, it will be very, very useful to you to use the similarity in solving problems. Okay, so that was our lecture number 39. There is one more thing which is mentioned in the lecture in the end, that the sides are proportional to K. Then what do we have? The ratio of proportionality of areas. So if two sides are proportional, if these two triangles ABC and PQR are similar, and suppose this ratio is equal to K, then what will be the ratio of their areas? So let us just look at it. If ABC is similar to PQR and the ratio of proportionality is K, ABC is similar to PQR and say AB upon PQ is equal to K, and all three are K, then what will be area ABC upon area PQR? This is interesting. Area ABC, let us take height H1 and height H2, okay, and we will eventually in the next lecture prove that the corresponding heights are also going to be proportional to the original sides. I mean, this ratio H1 upon H2 also will be K. Maybe we do this result in the next lecture when we learn complete meaning of similarity, where we can practice heights are also proportional, etc., and then maybe do this result. Okay, so area of two similar triangles and the ratio, they are proportional by the factor K square. We will look into the next lecture. Thank you.